Like I said earlier, the LSTM network, they do have three gates: the input, output, and forget gates. And the LSTM network contains information in a memory. This memory can be seen as a gated cell, meaning the cell decides whether or not to store a certain information or delete an information. That is, if it can open a gate or if it would not open a gate, based on the importance of how it assigns um, the information. The assigning of importance happens through weights, which are also learned by the algorithm. And this simply means that it learns it over time what information is important and what is not. Over here in this diagram, I would go further in describing what each of these gates does. A high level definition of this gate is that the input gate determines whether or not to let new inputs in. The forget gate would delete the information because it isn't important, or it decides if it's important or not. And then the output gates simply lets the impact come from the forget gate, and it would output at the current step. That's just the high level definition of what each of these gates mean. Coming back to this diagram, I would also be explaining how some of this information goes in the long-term, short-term memory network. Starting from the bottom here, that has the three arrows. It simply shows where the information flows into the input cell at multiple points. And that shows the combination of the present input, the past cell state, and also the cell itself. But also the three inputs flows over to the other gates and will decide how the inputs will be handled. The black dots that shows at each step here, it determines respectively whether to let new inputs in, erase the present cell state, and let the state impact the network's output at the present time state. The SC over here indicates the current state of the memory cell, and the GYN over here at the diagram is the current input to it. We also have to remember that each gate can be open or shut, and they will recombine their open and shut states at each step as we go. The cell can forget its state, or it can decide whether to be written or not, or it could decide whether it could be read from or not at each step. And this flows through each of the gates, through the input gates, the forget gate, and the output gate. The large three bold letters give us the result of each operation after it's done. That's just a brief explanation of the long-term memory gates. Now I would move over to how this is done in Python. Here is the code that was run. Before we run this, I used the stock prices from a certain website called Yahoo Finance, and I used the Tesla prices, and I'm just going to show how you could get historical data that could be ran in Python. When you get to the Yahoo Finance page, you click on Finance. After you click on Finance, you can simply click on any stock prices that you need. But for my project, I use the Tesla stock prices, and here is what it looks like, and then click on historical data. And then you have to, I specified the date that was to be used for my project. Made sure to make sure to show the historical prices, and then also set this to daily applied, and then downloaded that file. So that's just how you can get like the stock prices. So moving back to this, I imported my libraries. I used the pandas, the numpy, the sequential, also use the LSTM, use the dropout layer or dropout library, and then the dense layer. Also, we would use the time series generator and the min-max scaler. For my Tesla stock prices, I used the date October 13th of 2013 to 2018. And then I made sure I loaded that CSV file to the path. That way it would read my CSV file. And then to load my data set, I did that using the PD read underscore SCV to read my data set. And just to view what our data set looks like, I use the dot head to look at the dates, the open prices, the high, low, close, adjustment close, and the volume. Also performed a brief EDA on my data set. Looked at the shape, the types of what the data type of my data set, and then a statistical summary of what it looks like, such as the mean, the maximum, and also the standard deviation of my data set. Then I went ahead and I took out all the other variables. We just want to look at the closing price to predict the closing prices for the future. So I took out every other variables or every other attribute in my data set and left just the closing column. And then I plotted the variables, and this is what it looks like. And then for the input series, the number of time steps I used was 60. That is the number of time series I'll be used to predict the future ones. So I went ahead and left it as 60. And then next, when I trained my data set, splitting it into a training and testing set, used a percentage of 0.2 for my testing, and that's how much it's going to use in our data set. Then I went ahead and split the data into train and test. Just like it is here, it's 152. We'll be using 252 data values for our testing data set. And then the testing data set is going to start at this index, which is the values that fall into index 1008. Created a different one for my training data set since we already created one for our testing set. Went ahead and viewed the training data set, the first 5 values for the training, and also looked at the tail of the training sets, and looked at the first 5 values for my testing set, and also looked at the training set. Then I normalized my data into the scale range 0 to 1, like we did earlier for my training and data set, for my training set and my test set. Then I also created a time series generator for my training. I set that to 52. And over here, we build and train and test the model. I use 3 layers, layer 50 for my first model, 50 neurons, or 50 cells. Use the 0.2 for my dropout layer, the second layer 50, 0.2, and then for my dense layer, for the final prediction, I used just 1 layer. And then I went ahead to compile the model, train and fit the model, use the fit generator to go through a 50 epoch. It will run 50 times. And then I visualize the model performance after training. And this is what the plot looks like. For my prediction, I predicted using the time series generator. And over here, it shows the prediction for my next set of data sets. And then we also visualize that prediction here. And this is what it looks like. So now we move ahead to the time series forecasting for the long-term, short-term memory. I went ahead and brought in a new data set for a different value. We would also be using the time step of 60. And then to build and compile and fit this model, I ran this in 50 epoch. And then I used the forecast for this new values. It would forecast for the next 100 days from November to March of 2019. And going over here, we looked at the data frame of what it looks like, and then creating the new time stamp for this dates. And then we run the forecast.df to look at the forecasted value of what it's going to look like. And then we plot the forecast. And over here, it shows the new values that we imported, showing the new data sets. And then we run the forecast by the forecasted values. It would show the close and then the forecast values, and this is what it looks like. Pretty much this model is predicting the forecast very accurately, and I think the model did a good job with whatever the core parameters I chose for this data set. To redesign my model, I didn't really do much. The only thing I changed was to change the number of LSTM cells and also changed my dropout layer to 0.1. I changed this to 50, and then for my second layer, I changed that to 60 and left the third layer to be 60 as well. That was pretty much the only thing I changed. And then we ran everything, and this is what it looked like, which looks a little bit better, but I prefer the other model to whatever I changed in this core parameters. So yeah, this is a brief project on LSTM. I also learned how to run build, train, and test on a sine wave dataset, and also how to redesign my model. With this project, I have gotten a proper understanding on how the RNN network works, and also it has helped me to make a decision on if this is going to be the right algorithm to use in any given machine learning problem.